Please.
Hello, I'm listening. I'm listening.
Say, please, a body that can produce light.
They emit light on their own.
Good. These are bodies that give off light on their own. Okay. So by themselves, they can produce visible light. So luminous bodies emit light on or give off light on their own. And an example is the sun. Example, we have the sun, the stars. Okay, somebody talked about the firefly. Firefly. Then you also talked about the glowworm. The glowworm. So these are bodies that can by themselves produce light. Okay, sun, star, firefly, glowworm, etc. We have a lot of them. Then we have non-luminous bodies. Non-luminous bodies cannot produce light or emit light by themselves, but they usually reflect light from a luminous body. So they are bodies that are illuminated by another body. And a typical example of non-luminous body is the moon. And then glass or mirror. Okay. So non-luminous bodies do not produce light on their own, but reflect light from a source. So example, the moon. The moon, mirror, glass, etc. So they will often reflect light from a luminous source. Okay, so in fact, they say, because I've not been there before, they say that when you visit the moon atmosphere, there are shiny stones which always would reflect light from the sun and then beam it to the earth. Okay, so the moon is an example of a non-luminous body. Okay, then we have some sources we could describe as incandescent source of light. With incandescent source of light, these are bodies that will produce light when heated. And a typical example is a incandescent bulb. the tungsten filament. I don't know if you've seen one before, but these days, those bulbs are not so popular. Before, we had this 40 watts, 60 watts kind of bulb, which will produce light when it becomes so hot. I don't know if you've seen one before. They're round bulbs.
Yes, please.
Yes. That is an example of an incandescent source of light. It produces light when heated. The sun is also an example under this category. In as much as hello.
Mr. Dear, please, the bulb, is it the like orange colored one?
Usually that is not colored. That is not colored. Okay. Looks more like frosted, but in fact, it's usually very hot. And these days, it is used in the poultry farms because the day-old chicken would need light as well as heat. So these are the bulbs that are used in the poultry farm these days. Okay, the incandescent bulbs. Then I said the sun is also an example. Then fire from wood, stove, okay, they will produce light when heated. And so these are examples of incandescent. Then we have fluorescent source of light. Fluorescent sources are not usually heated, okay? They will produce light, all right, but not when heated. An example is the fluorescent tube. The fluorescent tube, then the now LED bulbs, energy saving bulbs, okay, we have around. They will produce light, but not when heated. Please, are we okay?
Answer, please. I have a question.
Ask your question.
Mr. Japanese, I thought these types of bulbs, they were like, have you seen that one where a filament to heat, blah, 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 then to light, blah, 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 then it's shining? Is that one the same as like this one? Like, have you seen that? I don't even know how to ask this question. Have you seen these bulbs? They are the ones that the filament to heat and light to, shine. But
Yes.
the old bulb, how are they?
That's the incandescent bulb. That's the incandescent.
So the fluorescent bulb is different. That one uses a different.
Exactly. The fluorescent bulb doesn't use the tungsten filament, which has to be heated, and as a result of it being heated, it glows naturally. No. So the fluorescent bulbs and then the energy saving bulbs we have around actually use different technology. And I'm sure we could all attest to the fact that the fluorescent bulb, the energy saving bulb, doesn't produce immense heat. So any source that produces less or no heat is a fluorescent type. Is that okay? All right. Have you any more questions?
Yes, Mr. Edgar.
Hello.
Please, can the sun be classified under the incandescent source of light?
Yes. The sun produces light when heated. So the light from the sun is associated with immense heat. So we produce we categorize it under incandescent sources.
Yes, thank you.
All right. Okay. All right. Then let's talk about rectilinear propagation of light. Rectilinear propagation of light. Rectilinear propagation of light talks about the fact that light travels in a straight line. So rectilinear propagation of light about the fact that light travels in a straight line. So, in your JHS lessons, to demonstrate rectilinear propagation of light, what you were doing is that you create a cardboard, about 3 or 4, then create a hole, then join the 3 cardboards with a thread, and then have a source of light at one end. Now, once they are arranged in tandem or orderliness, okay, when the holes are, okay, aligned, when you look at it from the other end, you see the source of the light. Now, when you displace, push, okay, or change the position of any one of them, you cannot see the light. To demonstrate the fact that light travels in a straight line. And this is a basic experiment you were doing in JHS, unless you didn't go to a good school. But if you went to a good school like my village school, you would definitely conduct that simple experiment to confirm that truly light travels in a straight line. Please, is that okay? So when you are asked to perform a basic or simple experiment to explain rectilinear propagation of light, please do revisit your JHS simple experiment on light, and that answers it. Are we okay?
Yes, please.
Okay.
Yes, please.
Let's talk about a ray. What is a ray of light? A ray of light. What is a ray of light? I'm coming, I'll answer your question. We'll get there. What is a ray of light? Adwa, what is a ray of light? A ray of light, okay, is a direction or path taken by light. So this is the direction or path taken by light. How do we represent a ray of light? A ray of light is represented by a bold line with an arrow in the middle. So symbolically, this is how we represent a ray. A bold line with an arrow in the middle. This is a ray of light. Please, in optics or analyte, when you draw just the line without the arrow, we won't mind you. So take note. So if you want to represent, tell us that this is a notation for a ray, then I expect to see a bold line with this arrow in the middle. Now, we also have what we call a beam of light. A beam. A beam of light. These are, what is a beam of light? A beam of light is about 2 or more rays. Okay? Or we talk about a beam when we have 2 or more rays. So whenever I have anything more than 1, this is a beam of light or rays. Are we okay? So this is parallel beam, a parallel beam of light. Then we have, okay, let me bring the rest here. Parallel beam of light. We have convergent beam. Convergent beam of light come from a common source or come from a source and they all meet at a point. So we say they converge at a point. So they will all come from an external source and then meet at a common point or one point. So this is convergent beam of light. Then we have divergent beam. Diverge means they spread out. So all the box or all the light will come from a common point, and as they go, they will all spread out. Okay. So we have this is divergent beam of light or rays. Please, are we okay?
Yes, please.
Hello?
Yes, please.
Okay. All right.
Mr.
Yes.
Mr. Dia, please, can you kindly take a shot?
I forgot to know. I'm coming. Adua, you also cannot see.
Please, I can see a bit.
A bit. All right, I'm coming. Okay, so I've sent it to the group. All right, so we were talking about some characteristics of light. some characteristics of light. Please, do I clean the board?
Yes, please, Mr. Edia.